Welcome to the Basic Warewash Training Course, AutoClaw Services e-learning online classes. In this module, we'll be learning and understanding electricity. This module will help you understand electricity, but will not certify you as an electrician. However, it will allow you to converse in proper terminology with team members and customers. The way water flows through a pipe is a simple way to compare the flow of electricity. The larger the pipe, the more water is able to flow through the pipe. If too much water is forced into the pipe will burst. The same way electricity flows through a wire is the same principle. The insulated jacket is the pipe. This jacket protects the electricity from leaking out. The wire inside the jacket is called a conductor. It is the path in which the electricity flows. When you need to deliver more amperage, the wire must be large enough to prevent it from exploding or overheating. First component of understanding electricity is going to be voltage. It is important to understand the differences between 110 to 240 volts single phase, 208 three-phase, 240 volts three-phase. Just like water needs pressure to force it through a hose, electrical current needs some force to make it flow. A volt is the measure of electric pressure. Utility companies connect power to a building by the use of transformers. These transformers reduce voltage to proper use levels. These use ranges may vary from area to area. As an example, 240 volts may actually read as 237 volts when reading voltage on a multimeter. These varied use ranges of voltage are common and will not adversely affect devices the voltage is operating. Understanding and recognizing different voltage levels such as single phase and three phase is important to your day-to-day work. Most all equipment we will experience in the field will have data plates describing the exact voltage, number of phases, and total amp draw. Let's take a look at 110 to 120 volt alternating current. This is going to be considered as a low voltage. It will have one hot leg, one leg to neutral, or we consider commons, and one leg as a designated ground. In our business, we use the terms of low voltage and high voltage. Low voltage is going to be anything that's under 200 volts of alternating current. High voltage is considered 200 volts and greater. The reason we need to know the difference between low voltage and high voltage is because you test differently using a multimeter. In testing low voltage with a multimeter, you would put one of your terminals on a hot leg and one terminal on your neutral or common. This connects the circuit, it completes it. If you was to put one leg on a hot and one terminal on the ground, this is wrong. It does not complete the circuit. Remember, low voltage, you must complete the circuit. One terminal from your multimeter must be on a hot leg and another goes to a common or a neutral. Let's take a look at 208 volts alternating current single phase. 208 volts single phase will have two hot legs of current and one designated ground. Now we're in high voltage. The testing with a voltmeter now changes. To be able to test with a voltmeter, we put one of our meter leads on L1 and the second meter lead on L2. We connect the circuit by testing across the two hot legs. To complete our testing process, individual leg to ensure that we have the correct voltage. In 208 volt single phase, each hot leg should have 120 volts of current. We take one of the meter leads and move to a ground and 1 meter lead on a hot leg. We ensure that we have 120 volts of current. Next, we move our meter lead to the second hot leg and we test to ensure that we have the correct voltage running through it. One of the problems that we do run across in our business is that periodically a hot leg will drop out. This can be caused by a couple of different items. One is that the power company can drop a leg from their transformer on the street to the building. Another problem is that we can have a problem with a switch, such as a contactor, not allowing current to come through one of the legs. Always ensure complete circuit of testing both hot legs together and then testing each individual leg to ensure that we have the correct voltage. Now let's take a look at 208 volt alternating current three-phase. In 208 volt three-phase, we now have 3 hot legs of current and 1 designated ground. To test three-phase power, we would take 1 meter lead and put it on L1, our second meter lead on L2. This completes a circuit to give us 208 volts. To complete our testing process, we now go from L1 to L3 and L2 to L3. This tests a complete circuit against all 3 legs. Next, we move 1 meter lead to a ground. Here we test each individual hot leg. Each hot leg on 208 volts three-phase should equal to 115 volts. We test all 3 legs to ensure that we have the proper voltage running through all 3 legs to our device. Let's move to 240 volt alternating current three-phase. As you will notice in the diagram, the wiring and color code is identical to 208. We have 3 legs of hot current and 1 designated ground. When testing with our multimeter, we do the same test process. 1 meter lead goes to L1, second meter lead to L2. Now we actually show 240 volts. We complete our testing program by going from L1 to L2, from L1 to L3, and then L2 to L3. Again, this completes the circuits across all 3 legs. Next, we move 1 meter lead to ground, and we test each individual leg. Each leg in 240 volt three-phase will now be equal to 120 volts each. We test all 3 legs to ensure we have proper voltage to all 3. Next, we move to 480 volts alternating current. This will be unusual that you'll run across this, but on occasions we will, depending on the type of customers we're connecting to. 480 volt three-phase also has 3 hot legs of current and 1 designated ground. In testing 480 volts, we put 1 meter lead on L1, 1 meter lead on L2. Completing a circuit, we should get 480 volts. The test process is the same as all other high voltage. We now test from L1 to L3, L2 to L3, and this completes the circuits across all 3 legs. Next, we move 1 meter lead to ground, and we test each individual leg. In 480 volts three-phase, each leg to ground should equal 277 volts. This completes the testing of three-phase. The next element in understanding electricity is current. Electric current is the movement of electrons from a negative point to a more positive point. There are two types of current that we will encounter in our work. Alternating current, or AC, it's best described as currents alternating from a positive to a negative. In our region of the world, this current alternates from a positive to a negative 60 times per second, or at 60 hertz. The electricity actually pulses through the wires. Alternating current is typically used to operate electric motors, heating elements, electromagnetic coils, and light bulbs. The second type of current we will encounter is direct current, or DC current. It is best described as current that flows from a negative voltage source through the load and back to the positive terminal of the voltage source. Direct current is typically used to operate a flashlight, crank a car, or drive a motor. The next point of electricity is the source. Electricity sources are defined as the resources for electric power. In our field of work, electric source is where our equipment is receiving its power from. The source can be from a circuit breaker, a wall outlet, batteries, a switch or disconnect. Each of these sources provides power to operate a device or a load, whether it is a dish machine, a motor, a heating element, or a light bulb. The next part of understanding electricity is a load. The load is an electrical component that consumes electrical power from the source, opposed to an electrical source which produces the power. Example of components considered loads when energized: a solenoid, a light bulb, washer-rinse motors, heating elements, and appliances. Remember, a load is a device that's actually consuming the electricity. Depending on which device is operating determines how much current this device demands. This is referred to and measured in amperes, or amps. Ampere. This is the basic unit of measurement of electrical currents. It can be defined as a measurement of the amount of electricity that is flowing through a circuit. Refer back to the analog of water passing through a pipe. If the water pressure is too high, the pipe will burst. If the flow of current is too high, the insulation and the wire will burn or the circuit breaker will trip. For more water to flow, you will need a larger pipe. For more current to flow or more amps drawn from the load, you will need a larger wire. The higher the load demand, the higher the amperage requirements to push the load. Have you ever used an extension cord working some type of motor device, pressure washer, saws, and when you go to unplug it, you feel that the wire is hot? One of the reasons that is it's drawing more electric current through the wire than the wire can afford to send through it. It is starting to cause it to overheat. Eventually, it's either going to burn, melt, or break. The second thing that happens in this scenario is it starts burning up the motors for the devices you're using. Look at the motors that you're trying to operate and look at the amperage of the wires of what it can carry. This will set it correctly so that your wires don't overheat. Now that we've covered basic electricity terms and a simple understanding of what electricity is, here's a simple troubleshooting of electrical problems. When resolving an electrical problem, follow these 5 simple steps. Determine the problem. First, listen to the owner or operator as to what he thinks is wrong. Always operate your equipment to verify the problem. Determine component relationship to the problem. Once you have established what should or should not be happening, determine exactly what components are involved and how they relate to one another. Simple question to ask yourself here: what am I expecting to happen and what causes that to happen? Set a logical checking sequence. A logical sequence would be as follows. Check the source. Check the breaker, the fuse box, outlet, or the on and off switch. Do you have power to your device? Check the circuit. Make sure proper voltage is available for each phase from the source to the load. Last, check the load. Verify that the load device is receiving proper voltage and that the load device is functioning properly. Compare measurements to specifications. By the use of the multimeter, verify that each circuit is opening and closing properly and that proper voltage is being supplied to the switches, coils, heating elements, etc. Follow the problem to its origin. It's a simple process of elimination. To help complete the understanding of learning about electricity, complete the program about using multimeters. Learn more about basic electricity by talking to your managers, regional manager, or vice president, or contact the training center for more information.